So next, for problem number 4, we have a particle is moving in a straight line motion. After 1.5 seconds, the particle is positioned 8 meters to the left from its starting point. If the particle's velocity is given by the equation velocity is equal to 16 minus 40 squared meters per second, calculate the change in position from t is equal to 0 to t is equal to 8 seconds, or 0 to 8 seconds. The distance that the particle has traveled during the given time period, and as well as the acceleration when t is equal to 5 seconds. So, medyo mahaba-haba. So, like the previous questions, the first thing that we're going to do is we're going to list the given values. So, one given value is the velocity. So, 16 minus 4 t squared, that is in meters per second. There. So the first thing that we're going to solve for is the time interval. So like the problem in number 2, I think, we're going to solve for the time interval. So we are going to get it from this equation. So v is equal to 16 minus 4t squared. So how are we going to solve for the time? So since this is equal to 0, we can transpose this value on the left side. So that will give us 4t squared is equal to 16. So to now we are going to find a way to just leave the value of, or the variable t here on the left side. So the first thing that we can do is we can divide both sides by 4 to omit the coefficient 4. So 16 divided by 4, we are going to have 16 4. So to omit this exponent, we can we can solve for the square root of both sides. So the square root of t squared is t. The square root of 4 is 2. So the value of t is 2. So for our time intervals, so since we only got one value, so this is going to be 0, this is 2, and then this is 8 seconds, 0 to 8, right? So these are our time intervals from 0 to 2, and then from 2 to 8. So now we are going to get the value of our first position. I think kasya naman dito. So again, to solve for position, the formula for that is v ds over dt. So again, the given value here is our velocity. So cross multiply, ds is equal to the value of velocity, which is 16 minus 4t squared multiplied by dt. So again, let us integrate both sides. This will become 0, and then simply s, and then 0 to, this is 0 to 2, right? So from 0 to 2, 0 to 2, yeah, there. So integral of ds is s minus 0, and then for this one, we are going to integrate first the values of 16, which is 16t, minus the integral of 4t squared, that will give us 4t cubed over 3, multiplied, limited to 0 to 2. So tanggalin na natin to. So s is equal to 16t, simply 16t minus 4t cubed over 3. So again, this is 0, so we are not going to solve for that na because it's 0. So the next thing that we're going to do is we're going to substitute the value of t, which is 2 seconds. So 16 multiplied by 2 minus 4 multiplied by 2 cube over 3. Calculating this will give us 21.33 meters. So this is our S1. So for the next time interval from 2 to 8 seconds, we have, so again, para mas mapadali na yung buhay natin, let us just copy the integrated form of the velocity, which is the 16t minus 4t cube over 3 limited to, again, for our next time interval, 2 and then 8. So we are just going to substitute these time intervals. So let us start off with 8 minus, so substitute lang, cube over 3 there, and then minus 16 multiplied by this time interval, which is 2 minus 4 2 cube over 3. So calculating this will give us S2 is equal to negative 576 meters, or simply 576 meters. Let us just omit this. There. So that is our second position. So now that we are done calculating the values of our positions, which are S2 and S1, the next thing that we are going to do is to calculate for the total distance. So S total. So in order for us to get the total distance, we are just going to sum up the value of our S1 and S2. S1, which is 21.33, plus our S2, which is 576 meters. So calculating this will give us 597.33 meters. So this is our value for the total distance. So the next thing that we're going to solve for is the change in position. So in order for us to get the change in position, we are just going to simply subtract the value of the S2 and from the S1. So S2 minus S1. So S2, which is 576 meters, minus the S1, which is 21.33. So this equation will give us 554.67 meters. So this is our value for the change in position. So lastly, the last requirement for this problem is the acceleration. So again, the formula for acceleration is a dv over dt. So since we have a value for velocity, we are just going to substitute that value. So velocity is equal to 16 minus 4t squared there over dt. So d over dt, we are going to get the derivative of these terms. So 16, the derivative of 16 will be 0. So the derivative of negative 4t squared is negative 8t. So the last thing that we are going to do is we are going to substitute the value of t, which is 5 seconds. So negative 8 multiplied by 5, that will give us negative 40. So since it is acceleration, the unit for that is negative 40 meters per second squared. So those are the problems under dynamics of rigid bodies. So see you on my next video. Thank you for watching.